Hello, good morning, students. Let us try to understand the pH scale, student, and the pH measurement. Also, we'll try to study in this video lecture. So, when you talk about pH, student, okay, so pH is also known as the hydrogen ion concentration. So, the pH scale was introduced by SPL Sorensen. Okay, SPL Sorensen was the first person who discovered the pH scale, and he said that his pH of a solution is defined as the negative logarithm to the base 10 of activity of hydrogen ion. Okay, so activity of hydrogen ion is equal to, that is molar concentration of H, that is mole per liter. pH is equal to minus log A H, that is equal to minus log H plus ion concentration. And H, if you are calculating H plus ion concentration, equal to 10 power pH. So this is what the relation is, student, that we have to keep in mind, that pH is equal to minus log hydrogen ion concentration, or H plus ion concentration is equal to 10 power pH. For any aqueous solution, the sum of pH and pOH depends on the ionic product of water, that is pH plus pOH is equal to pKw at any temperature. At 25 degrees Celsius, the any aqueous solution pH plus pOH equal to 14. At 25 degrees Celsius, the pH scale lies between 0 to 14. And at 25 degrees Celsius, pure water or neutral solution has pH is equal to pOH is equal to 7. pH of some common substances are like that. Gastric juice is 1.2, highly acidic, student. Blood plasma is there 7.4, and egg is there 7.8. If the aqueous solution of an acid is diluted with water, its pH value increases. Okay, if aqueous solution of an acid is diluted with water, its pH value increases after dilution. What do you mean by, again, you see, if the aqueous solution of an acid is diluted with water, pH value will increase. It means that acidic nature will decrease. Now pH is equal to initial pH plus log V2 upon V1. This is what the dilution, pH is equal to initial pH, then log V2 upon V1. That is V1 initial volume of the solution, and V2 is volume of solution after dilution. If the aqueous solution of a base is diluted with water, its pH value decreases. If the aqueous solution of base is diluted with water, the pH value will decreases after dilution. So pH is equal to P initial, initial pH minus log V2 upon V1. V1 is initial volume of solution, and V2 is the volume of solution after dilution. Whatever the volume of water is added, the pH of acid is always less than 7. Whatever the volume of water is added, the pH of acid is always less than 7, and base is always more than 7 at 25 degrees Celsius. It's very diluted. If a very dilute acid is added to concentrated acid, the very dilute acid is treated as water for the purpose of calculating the pH value of water mixture. Okay, if a very dilute acid is added to a concentrated acid, the very dilute acid is treated as water for the purpose of calculating the pH value of mixture. If very dilute base is added to the concentrated base, the very dilute base is treated as water for the purpose of calculating pH value of mixture. If aqueous solution of an acid is diluted by 10 times, the pH of the solution increase by 1 unit. If the aqueous solution of an acid is diluted by 10 times, the pH of the solution increase by 1 unit. 100 time, okay, this is 1. If the if the aqueous solution of an acid is diluted by 10 times, the pH of solution increase by 1 unit. 100 times, the pH of solution increases by 2 unit, and 1000 times, the pH of solution increases by 3 unit. If the aqueous solution of base is diluted by 10 times, the pH of solution decreased by 1 unit. 100 times, the pH of solution decreased by 2 unit, and 1000 times, the pH of solution decreased by 3 unit. For any strong acid, hydrogen ion concentration is equal to normality of solution. For any strong base, hydroxide ion concentration is equal to normality of solution. If two strong acids are mixed, then hydrogen ion concentration equal to N1B1 plus N2B2 upon N1 plus B1 plus B2. If strong base are mixed, N1B1 plus N2B2 upon B1 plus B2. If excess of strong acid is added to limited quantity of strong base, so hydrogen ion concentration is equal to NaVa minus NbVb upon Ba plus Bv. NaVa means normality of acid and volume of acid. If excess of strong base is added to limited quantity of acid, so that is OH minus ion NbVb minus NaVa and upon Ba plus Bv. Solution NPOH, hydrogen ion concentration, OH ion concentration, pH. Acidic solution more than 7. Okay, so hydrogen ion concentration is more than 10 power minus 7 and hydroxide less than 10 power minus 7, and that is pH will be less than 7. Neutral will be 7 and basic will be more than 7. Measurement of the pH of solution is very essential. Of its value should be known when dealing with the biological cosmetic applications. pH of solution can be found roughly with the help of the pH paper that has different color in the solution of different pH. For example, let us have a look over the question, student. 100 ml of 0.15 molar HCl are mixed with 100 ml of 0.05 molar HCl. What is the pH of a resulting solution? So hydrogen ion concentration is equal to NaPa N1V1 plus N2V2 upon V1 plus V2. This is the value is given, student, 0.41 molar and 0.05 molar. So and volume is the 100 ml is there. So you multiply, it is coming 10 power minus 1 normal. So pH is equal to minus log hydrogen ion concentration. So equal to minus log 10 power minus 1. That is the pH is 1. Another question, 50 liter of 0.1 molar HCl thoroughly mixed with 50 liter of 0.2 molar NaOH. What is the pH of the resulting solution? So OH ion concentration is B1 N1 N1 B1 plus N2 B2 upon B1 plus B2. So this is coming value is 0.05. So pH is equal to minus log OH ion concentration. So minus log 5 into 10 power minus 2. So that is equal to 2 minus log 5. So that is 1.3. So pH, POH is equal to 10 power minus 3. So this is all about the pH, student. Thank you so much for watching. Try to solve the more problem on the basis of pH, student. You will be able to be good at the pH. Thank you so much for watching, friends.